When you initially enter the cockpit, all the EIS displays are normally off. The displays require AC electrical power to operate, so unless either the APU or a ground electrical supply are available, the displays will not operate. We will connect a ground electrical supply for you. Once AC power is available, the displays can be switched on. First, let's switch on the PFD. After a short delay, some information will be displayed. Because there is no data from the Air Data and Inertial Reference System, ADIRS, there are only failure flags showing. Now, turn on the ND. Both the ND brightness and the weather radar brightness are normally set to full bright at the same time. The brightness levels of both EIS screens are later adjusted to suit the ambient light conditions. Just like the PFD, after a short delay, the display will be visible, but limited to failure flags, because there is no data from either the ADIRS or the FMGS. You will see how the information changes on the PFD and ND as the ADIRS and FMGS come online later in the course. The ADIRS system is now switched on, and the PFD will display attitude, speed and altitude data. Notice that the indication on the altimeter scale is showing a negative value because a wrong QNH is set. The correct QNH is 1013, so the baro setting knob on the EIS control panel is rotated to change the setting. The QNH is set, and the negative indication has been removed from the altimeter scale. The setting of the ND mode selector and range will depend on the departure profile. This will be discussed in the FMGS modules, but we have already set ARC and 10 miles for you. When the ADIRS system is fully aligned and the FMGS is programmed, the data displayed on the PFD and ND is more complete. The choice of which additional information selector is used will depend on the departure, but normally the pilot flying has constraint selected. A green indicator illuminates in the push-button switch to show that you have selected it. The selection of the VOR ADF selectors will depend on the navigation aids used for the departure. This will be discussed in the navigation modules. Now let's look at another selection on the EIS control panel. An automatic function that occurred as the aircraft was powered up was that the FDs were switched on. This automatic function occurred because the normal mode of operation on the A320 is with FDs on. Notice that the green indicator on the flight director push button is illuminated, and that there are indications in the top right-hand corner of the PFD. Look carefully at the PFD. This indication tells you that Flight Director 1, Captain, and Flight Director 2, First Officer, are switched on. Notice that there are no Flight Director crossbars displayed. This is normal because on the ground they are not required. You will see later that during the takeoff, the Flight Director command bars will automatically appear. You will see more on Flight Director in the Autoflight modules. If the aircraft is being completely shut down, the EIS displays are turned off using the appropriate brightness controls. When you initially enter the cockpit, all the EIS displays are normally off. The displays require AC electrical power to operate, so unless either the APU or a ground electrical supply are available, the displays will not operate. We will connect a ground electrical supply for you. The ground electrical supply is connected and powering the aircraft. Normally, the ECAM screens are switched on. First the upper, then the lower. For training purposes, let's switch them on in reverse order to see what happens. Switch on the lower ECAM display. Notice that engine warning display information is displayed on the lower ECAM screen. This occurs because it has priority. Therefore, if there is only one ECAM screen available, the engine warning display information will be displayed. Now switch on the upper ECAM display to see what happens. Notice that the engine warning display information moves to its normal position on the upper ECAM screen, and the door oxygen system page is displayed on the lower ECAM screen. The door oxygen page is what the ECAM system will automatically display because you are on the ground with the doors open. The memo area of the engine warning display has a message telling you that refueling is taking place. We will now start the APU. Notice that the APU system page is automatically displayed by the ECAM system. There is no light on the ECAM control panel, ECP, APU key, because the APU page has been automatically called as part of a normal sequence. The APU is now running. Shortly after the APU start, the ECAM door oxygen page is automatically recalled. The next action is to press the recall key on the ECP for at least 3 seconds. Pressing this key recalls any warnings or cautions that have been cleared since the last power-up. Since we are performing a cold start of the aircraft, a normal memo will be seen on the engine warning display, because there is nothing to recall. If we were on a turnaround, the display would recall any warnings or cautions that had occurred on the previous flight. In this example, a cancelled caution concerning the Digital Flight Data Recorder, DFDR, has been recalled. You will see how a caution is cancelled in the Abnormal Operation module. During the pre-flight, one of the things we do is to check fluid levels: engine oil, hydraulic fluid, fuel. The required system pages are manually called by pressing the associated key on the ECP. Let's call the ECAM hydraulic system page. The ECAM hydraulic system page is displayed. Notice that there is a light on the hydraulic key on the ECP to indicate that it was manually selected. You will do the fluid level check in the hydraulic module. So let's see how to return to the ECAM door oxygen page. To deselect a manually selected ECAM page, press the ECP lighted key. The ECAM door oxygen page is displayed, and there are no lights on the ECP. Remember the lights out philosophy. The switching panel is checked to confirm that all the switches are in their normal position. The passengers have boarded, the doors have been closed, and the aircraft is ready for pushback. Notice that on the door oxygen page there are green indications on all the doors, which means that you are in a go state. When the ground personnel attach a tow bar to the aircraft, they disconnect part of the nose wheel steering system. The ECAM system will detect this and provide a green memo indication: nose wheel steering disconnected. Let's start the engines. The ECAM system will automatically display the ECAM engine page during engine start. Notice that as soon as the first engine is running, the nose wheel steering disconnected memo changes to amber. This happens because ECAM has detected that you are capable of taxiing, but you have the steering disconnected. The pushback is complete. Both engines are running, and the parking brake has been set on. Notice that when the ground personnel reconnects the nose wheel steering, the amber memo disappears. The ECAM wheel page is automatically called, so that during taxi, the brake temperatures can be monitored. Part of the after-start checks involves arming the ground spoilers and setting the flaps. We have armed the ground spoilers for you. A memo appears on the engine warning display showing that the ground spoilers have been armed, and the flap indication changes to show the flap setting. Another part of the after-start checks involves checking the status page. In the example shown, there is no status reminder at the bottom of the engine warning display. That means the status page is empty. The APU is no longer required, so we have switched it off for you. All that remains in the right-hand memo area is the parking brake message. The door oxygen page should be checked to confirm that all slides are armed before commencing the taxi. On the ECAM door oxygen page, observe that there are no amber indications and that there are 6 white slide indications. You will see more about the door oxygen page in the doors modules. The ECAM door oxygen page is replaced by the wheel page. The aircraft is now ready to taxi. The brakes are released, which clears the park brake memo, and the clock elapsed time is set to run. The elapsed time is now running, and the aircraft is taxiing out. The flight controls are checked during the taxi out. The ECAM system automatically calls the ECAM flight control page as soon as any of the flight controls are moved on the ground. Approximately 2 minutes after the second engine has been started, a Takeoff TO memo appears on the engine warning display. The Takeoff memo lists a series of actions required by the crew for the aircraft to be ready for takeoff. If you look at the list, you can see that there are blue actioned items remaining, specifically setting the auto brake to max and a takeoff configuration test. We will set the auto brakes to max for you. The blue action comment changed to green and moved. Just before completing the before takeoff checklist, the takeoff configuration test is carried out. This is done by pressing the takeoff configuration key on the ECP. By selecting the takeoff configuration key, the ECAM system simulates the application of takeoff power. If the aircraft is not in a takeoff configuration, for example flaps not in the correct configuration, then an ECAM warning or caution will be triggered. Provided ECAM detects that the aircraft is in a normal configuration, then the takeoff configuration memo changes to normal. Observe that there are no blue action lines on the engine warning display. We are now taking off, about to apply takeoff power. If required, the chronometer may be started. Observe that the chronometer has started. When the engines are set to takeoff thrust, the ECAM engine page is automatically called. On the engine warning display, notice that the takeoff memo is replaced by normal memos. A magenta takeoff inhibit message has appeared. The takeoff inhibit message advises you that some warnings and cautions have been inhibited during the takeoff phase. The aircraft is now airborne. After passing 1500 feet above aerodrome level, or 2 minutes after liftoff, the takeoff inhibit ceases and the memo is removed. At the acceleration altitude, the climb phase is activated. The aircraft accelerates and the flaps are then retracted, step by step, when reaching sufficient speed. When the flaps are fully retracted, the ECAM engine page is automatically replaced by the cruise page. The aircraft is now established in cruise. Periodically, a routine review of the system pages is carried out. Notice that while the engine page is displayed, the corresponding light on ECP engine key is illuminated. You will study the indications of the system pages in the appropriate modules, so let's continue with the review. Let's continue the review. Call the ECAM pressurization page. To continue the review, we will do the action for you. First of all, we will call the electrical page. Now the hydraulic page. Now the fuel page. Now the APU page. Notice that there are amber indications on the APU page. Because the APU is shut down, these are acceptable for this stage of flight. We will now call the ECAM conditioning page. The ECAM door oxygen page. The ECAM wheel page. The ECAM flight control page. After reviewing the flight control page, the cruise page can be recalled. Notice that there is no key to select the cruise page. You have to deselect the manually selected page. The cruise page is displayed and the ECP has no lights illuminated. Checking all the ECAM pages in cruise is normally done by pushing the All key on the ECP. This way of operating should not be associated with abnormal operation. We will now establish a descent for landing at our destination. As part of the approach checks, the status page is checked. Since there is no status reminder on the engine warning display, the status page is normal. The aircraft is lined up on final approach. As the landing gear is extended, the ECAM system will automatically display the wheel page. The wheel page is displayed to provide information useful for the landing. For example, brake temperature and spoiler deployment. On passing 1500 feet, with the gear down, a landing memo appears on the engine warning display. Notice that there is a blue action remaining, advising you to arm the spoilers. We will arm them for you. The blue action line is replaced by a green action completed indication. Notice that there are now no blue action lines outstanding. At approximately 800 feet, the landing inhibit becomes active, and this is indicated by a magenta memo. The landing inhibit message advises you that the vast majority of warnings and cautions have been inhibited during the landing phase. On landing, the chronometer can be stopped to give an indication of flight time. The chronometer only indicates up to 60 minutes and then starts again at 0. There is no indication for the number of hours. When the aircraft is finally parked, the elapsed time can be stopped by moving the selector to Stop. In this example, the block time is 4 hours and 8 minutes. At engine shutdown, the ECAM door oxygen page is automatically recalled so that you can check slide disarming. Notice the pulsing status message on the engine warning display. This is telling you that there is a maintenance-related message on the status page that you have not seen. There is a white maintenance status message at the bottom of the status page. This message is an indication for maintenance personnel that a system requires a maintenance procedure at the next programmed servicing. it does not mean that the aircraft is unserviceable. If the aircraft is being completely shut down, the ECAM displays are turned off using the appropriate brightness controls. Normally, DMC-1 supplies the captain's PFD, ND and the upper ECAM screen. DMC-2 supplies the first officer's PFD, ND and the lower ECAM screen. DMC-3 is available as a backup. Let's see what happens if DMC-1 should fail. For this exercise, you are the captain and you are the pilot flying. When DMC-1 fails, the captain's PFD and ND are lost, along with the upper ECAM screen. Since you no longer have any information to safely fly the aircraft, you should hand over control to the first officer. You are now the pilot non-flying. Notice that all three displays have a diagonal white line through them. The white lines indicate that the displays are working but are not receiving any data. As soon as the ECAM system detects the failure of DMC-1, you will get the standard sequence of alerts. You hear a single chime and see the master caution light. Cancel the master caution. Notice that the engine warning display has automatically transferred to the lower ECAM screen and is now receiving information from DMC-2. So that you can carry out the ECAM procedure, we will bring up the lower part of the engine warning display and the switching panel for you. The ECAM procedure requires you to select Captain on the EIS DMC switch located on the switching panel. DMC-3 will now supply information to the three displays, and the engine warning display is automatically transferred back to the upper ECAM display. We can now complete the ECAM procedure. After confirmation from the other pilot, the EIS DMC fault message can be cleared. The line on the engine warning display is cleared, and the status page automatically called. There is a memo to tell you that the configuration of the switching panel is non-standard. Notice the inoperative DMC-1 is shown on the status page. After review of the status page by both pilots, the ECAM procedure can be completed. The cruise page is displayed on the lower ECAM screen, and none of the keys on the ECP are illuminated. A boxed status message appears on the engine warning display to remind you that there is a message on the status page. This completes the procedure for a DMC-1 fault. If a single display unit fails, there are several ways that the EIS can be reconfigured to ensure that the pilots have all the information that they need. Let's look at several cases of this. If a PFD screen fails, the screen will be blank. There is no white diagonal line, since this is a screen failure, not a loss of data. Because the PFD has priority, the EIS will automatically transfer the PFD to the remaining screen. If an ND fails, no automatic transfer takes place. If required, the PFD-ND transfer switch can be used to manually transfer navigation information to the remaining screen. Should a failure of the upper ECAM display screen occur, an automatic transfer of the engine warning display to the lower ECAM screen takes place. Like the PFD, the engine warning display has priority over the system display. System pages can be displayed by using the system keys on the ECP. You have to push and hold a key to temporarily display a system page. While the system page is displayed, a white light illuminates on the key. Note, if a key is held down for more than 30 seconds, the engine warning display screen will be recalled automatically. This happens because the ECAM system assigns priority to the engine warning display. As soon as the key is released, the light goes out and the engine warning display reappears on the lower ECAM screen. If you need a system screen, you can transfer the system display to one of the ND screens using the ECAM ND transfer switch on the switching panel. By selecting the ECAM ND transfer selector to First Officer, the system display has been transferred to the First Officer's FO ND screen. Notice that the ND is replaced by the system display. It is not transferred. Normal selection of system pages is then available via the ECP. In the unlikely event that both ECAM displays fail, the ECAM ND transfer selector can be used to display the engine warning display on one of the ND units. As you can see, the First Officer now has the engine warning display on his ND screen. If you need to look at a system page, this can be done by pressing and holding the related system page key on the ECP for a maximum of 30 seconds. As soon as the system key is released, the engine warning display returns and the light on the ECP is extinguished. When you are limited to a single ECAM screen, the handling of system malfunctions and how you are advised of failures is slightly different. For clarity, we will concentrate on the ECAM screen. If an advisory condition arises, the relevant system page is not automatically displayed. Instead, the light on the key for the system and a boxed advisory message on the engine warning display will flash. If an ECAM warning or caution is triggered, then there will be no automatic display of the relevant system page. System pages should be called by manual selection on the ECP. To see this more clearly, let's look at a failure. We will only discuss the one ECAM screen and the selections on the ECP. You hear a single chime and see the master caution light. When a failure is detected, ECAM will give the normal oral and visual indications. On the engine warning display, the failure message will be displayed, and on the ECP, the two clear keys will be illuminated. By looking at the underlined system title, you can see which system page needs to be viewed. In this example, the fuel page key should be selected and held on the ECP. The system page can be studied to provide more information about the failure and then the key released. The engine warning display returns and the ECAM actions can be carried out. We will do these actions for you. Now the ECAM actions have been completed and only the failure title remains. To confirm what effect the actions have had on the system, reselect the fuel page on the ECP. As before, the fuel page is displayed while the key is depressed. You can see on the system page that the cross feed is connected and the pump has shut down. As soon as the key is released, the engine warning display returns. To continue with ECAM, a clear key should be pressed to remove the failure message on the engine warning display. Normally, the status page would be displayed, but with only a single ECAM screen available, the status page must be manually selected. Notice that there is a boxed status symbol on the engine warning display. The status key should be held down and the status page reviewed. The status page can be displayed for up to 3 minutes before an automatic return to the engine warning display occurs. Once the review is complete, the key is released and the engine warning display returns. The ECAM procedure is now complete. There are no lights on the ECP. During the approach phase, there is no automatic call of the status page when the flap selector is moved. To remind the pilots to review status, the boxed status symbol on the engine warning display pulses. The status page should be selected as before. In this module, we have looked at various failures associated with the EIS. You will have the opportunity to practice the various failures during the simulator phase.